Hi everyone, welcome to my video on absolute value in my Mathematics Essentials series. So there's a few ways to think about absolute value, but if you want to sum it up in a single word, it's just size. Okay, it just means the size of a real number. Okay, so let's define it more formally. The absolute value, it's often called the modulus as well. So the absolute value or the modulus, actually I'll write that. Modulus. Okay, just pretend I wrote or modulus of a real number x is given by this definition here. So we use these vertical bars either side of the x to denote absolute value. Okay, it's given by the absolute value of x equal to, we write this big set brace because this definition is what's called a piecewise definition. Okay, and if you end up doing mathematics, you'll become pretty familiar with piecewise definitions and piecewise functions. Okay, they're used whenever you have to give conditions for what something equals. Okay, so it's going to equal this if that condition is met, and it's going to equal something else if some other condition is met. And it doesn't have to be two conditions, you could have several conditions. Okay, but when it comes to absolute value, the absolute value of x is equal to x if this condition is met. If x is greater than or equal to 0, and it's going to equal negative x if x is less than 0. Now if we draw a number line, just draw a little number line here. Okay, all of the cases for x being greater than or equal to 0 or less than or equal to 0, okay, of all of those cases, one of them must be the actual case, whatever x happens to be. Okay, so if we say that this is 0, well, either, if we look at the first condition, either it's going to be somewhere over here because it's greater than 0, or it's actually going to equal 0. Okay, so that's the first condition. Okay, or it's just going to be strictly less than 0. Okay, it has to be one of those three: less than 0, greater than 0, or equal to 0. Now, I find that this can sometimes confuse people because absolute value is always positive. So the absolute value of some number is always positive. It's never negative. So it can be confusing sometimes to see a negative sign here. You're saying, hang on a second, absolute value is always positive, but you're telling me that in some cases it equals negative x. Well, let's resolve this confusion, okay? Notice that in the case where x is less than 0, what we are saying is that x is negative. Okay, which means we have to do something to x before we can make it positive. Okay, if we want the absolute value of x to always be positive, well, if x was negative, we can't leave it that way. Okay, we can't get a negative number from the absolute value. Okay, so if you've got something negative, what this part, so this part of the condition says, if you've got a negative number, then put another negative sign in front of it, because that's like saying -1 times -1, and they will cancel and give you a positive, because a negative times a negative is a positive. So let's just look at an example. Okay, let's say that x equals, I'll keep writing in red. Let's say that x equals 2. Okay, well, the definition tells us that when x is greater than or equal to 0, and that's the condition we have when x is equal to 2, okay, 2 is greater than 0, well then the absolute value of x, which in this case is 2, is just going to be 2. Okay, in other words, the size of 2 is 2. Okay, but let's say this time x equals negative 2. Okay, if x equals negative 2, let's look at the definition and see what it tells us to do when we have an x that is less than 0, which is what we have with negative 2. Okay, well then it says times it by negative 1. Okay, so the absolute value of x would equal the absolute value of negative 2, okay, because x equals negative 2, and that says put another negative sign in front of it. So we'd have negative negative 2, which is positive 2. Okay, so just in case this part of the definition has ever been confusing, I hope that resolves it. Okay, there's another way, well, there's several ways to think of absolute value. There's another way to think of it in terms of functions, so if it was a function, let's say we had f of x, oops, I wrote an absolute value bar. Okay, let's say we had f of x equals the absolute value of x. So this is basically the same as saying y equals the absolute value of x. Okay, I'm a bit reluctant to really talk about this way of thinking about it because you may not have seen functions yet. Okay, but if you have seen functions, this will be intuitive, I think. I would like to close that thing I opened. There we go. Okay, so let's say I have an xy plane, a Cartesian plane. Okay, and this here, well, that's the x-axis, and this here, this is the y-axis up here. Okay, if you were to think geometrically and think of what the graph of the function y equal to the absolute value of x would look like, well, the definition is saying, look, if you want to graph it, when you graph x, okay, or when your input into the function, in other words, your x value is positive, okay, graph y equals x. Okay, so maybe if I wrote this here, so, oops. So, y equals the absolute value of x, which would equal x, where x is greater than or equal to 0, and negative x, where x is strictly less than 0. So if you're familiar with functions, you'll know that y equals x is just a straight line. Oops. Okay, it would just be a straight line. Okay, on a Cartesian plane, it would just look like this. Okay, that's it there, y equals x. But notice that for all of the positive x values, we have y equals x, and for all of the negative x values, we have y equals x. Okay, consider what the graph of y equals negative x looks like. So here, again, is a Cartesian plane, or an xy plane. Okay, well, the graph of negative x would just look like this. Okay, I'll talk about a number of ways to think about absolute value in case you haven't seen functions like this, but this is the graph of y equals negative x, y equals negative x, and notice that whether our x values are positive and whether our x values are negative, our graph is always just y equals x. Well, absolute value says that, look, when you go to graph this function, if you are graphing for x values that are positive, graph y equals x. Okay? When they are positive or negative. When they are positive or 0, you graph y equals x. But as soon as you get to x values that are negative, so that would be, on the left of 0, you should graph a different function. Okay? You should graph this one, y equals negative x. So that would be like this. And you see, you get a function that looks like this. So you can think of this definition, okay, if you're treating the absolute value of x as a function, f of x equals the absolute value of x, or y equals the absolute value of x, it's saying, look, for all the positive values of x, graph the line y equals x, and for all the negative values of x, graph the line with negative slope, y equals negative x. Okay, so that's one way to think of it in terms of functions. Another way to think of it is in terms of distance from zero. So I'll write the definition again. The absolute value of x, the absolute value of a real number x is equal to x if x is greater than or equal to 0, and negative x if x is strictly less than 0. So we can think of this as distance from 0. Okay, the absolute value of x is just how far away it is from 0. So let's draw another number line. Okay, well, let's think of x equals 2. All right, so here's 0, and let's say 2 is here. Well, how many units away from 0 is 2? Well, that's what the absolute value of 2 would be asking. How many units away from 0 is 2? Well, it's 2 units away from 0. Its distance from 0 is 2 units. Okay, well, it's straightforward enough, but consider this. What if x equaled negative 2? So here would be negative 1, and here would be negative 2. Okay, well, note that negative 2 is also 2 units away from 0. Okay, so its distance from 0, the absolute value of negative 2, is also going to be 2. Okay, so that's a geometric way of thinking about it, whereas the algebraic way of thinking about it says, well, the absolute value of 2 is what you get from just timesing negative 2 by negative 1 to make it positive and get 2. Okay, so that's more of an algebraic interpretation. I mean, they are equivalent, but it's much more helpful to think of it geometrically or graphically. Okay, another more intuitive way to think about it is just physical distance. So physical distance can't be negative. Okay, if I ask you how far it is from your house to the local greengrocers, well, it wouldn't make sense for you to give me a negative number. Okay, the number you would give me is positive. Thinking about this on a number line, before we were talking about 0 and 2 or 0 and negative 2, let's just think about locations. Okay, so I live in Australia. Okay, and in Australia, there are, well, two of the states are called Queensland and Melbourne. Sorry, Queensland and Victoria. Okay, now the capital city of Victoria is Melbourne. It's a very nice city. And the capital city of Queensland is called Brisbane. It's also a nice city. Now, let's imagine that we thought of traveling from Brisbane to Melbourne, just like on a number line, as going in a positive direction. Okay, and we thought of traveling from Melbourne to Brisbane as going in a negative direction. Okay, let's imagine we are flying in straight lines from Brisbane to Melbourne, and we are taking off and landing at the same airports. Whether we go from Brisbane to Melbourne or Melbourne to Brisbane, we're flying in a straight path and we're using the same airports. Well, intuitively, the distance between Brisbane and Melbourne is the same as the distance from Melbourne to Brisbane. Okay? That's basically what we're saying when we say that the absolute value of 2 is equal to 2 and the absolute value of negative 2 is equal to 2. If you think about one of these cities as 2 and one of them as 0, or one of them as -2 and one of them as 0, okay, you are going to be traveling the same distance. So let's say this is 2, that's 0, and that's -2, and let's imagine that they are cities, okay? Now, they're equally spaced out. If you wanted to walk from this city to that city, how many units do you have to cover? You have to cover 2 units, but if you wanted to walk instead in this negative direction from that city to this city on the left, you would have to walk the same amount of distance, okay? So, to sum this all up, for every real number x, its absolute value is greater than or equal to 0. Okay, maybe tempting sometimes to think of absolute value in some kind of algebraic terms or from an algebraic perspective, and indeed the definition is an algebraic definition. I'll write it again. Okay, this is an algebraic definition. The absolute value of x equals x if x is greater than or equal to 0, and equals -x if x is strictly less than 0. Okay, that's an algebraic definition. All right, but it's much more intuitive and easier to think about if we think about absolute value as distance from 0. Okay? I think, you know, there's more I'd like to do on absolute value, but I might save it for the next video so that this one isn't too long. Yeah, I know when I first saw absolute value, I was confused by this. So maybe people don't get confused by this and it's just me. But I remember when I first learned about absolute value, I was like, what? That's weird. It kind of puzzled me for a little bit until a teacher clarified it for me. So in the algebraic definition, it can get a bit confusing when you see it for the first time because you are told ad nauseum that absolute value is always positive, but then you see that it equals something negative. Okay, well, it doesn't actually equal something negative. That's just accounting for the case where x is already negative and you need to times it by -1 to make it positive. This is the function, okay, f of x equals the absolute value of x, so this here. And, you know, for positive values of x, it's telling you to graph the line or the linear function y equals x. And for negative values of x, it's telling you to graph this line, okay, which is just y equals x reflected about the xy plane. So that's just the function y equals -x. That's another way to think of it in terms of functions. So don't worry if you haven't covered functions or seen them yet. We will talk about them later on in the series. Another way to think of it is, and probably the best way to think of it, is just the size of a number. Well, you know, if you're going to be doing more pure mathematics, you will end up becoming used to thinking of the absolute value of x as, you know, its size or its distance from 0. And if you're going into something more like engineering or physics or something like that, you'll probably be using your mathematics in a lot of applied settings, so you'll probably become accustomed to thinking of the absolute value of x as to do with actual physical distances between things. So absolute value of x being distance from 0, you will probably define some object, some physical object to be 0, and, you know, x to denote something else physical, and you'll be thinking of absolute value as actual physical distance between them. So there's a number of ways to think about it. I hope this video helps. If you enjoyed it, give it a like. If you want to see more, subscribe. I will say a bit more on absolute value in the next video and then go through some of its properties. Okay, and then I'll get on to sigma, otherwise known as summation notation, and maybe do a few problems. So that wraps up this video. Bye for now.